This lesson, let's talk about a new unit you will learn in English called radians. So what are radians used for? They can nicely connect the lengths of a circle with angles. So for example, if you draw a circle, so what's its circumference? Do you remember the formula for its circumference? It's C equals 2 pi r. You could either use C or L to represent its length, and the formula for it is 2 pi r. And the definition of a radian starts from the circle center. For the corresponding sector, if the arc length of the sector is r, if arc length is r, so the corresponding angle is 1 radian, and that's the official definition. So look at a circle circumference. How many r's are there in a circle? So you say L equals 2 pi r, and if you treat pi as a number, so there is 2 pi r, 2 pi times r for the whole round. And for 1 r corresponds to 1 radian. So for the whole circles, it's 360 degrees equals 2 pi radians, because you have 2 pi radians r. And so 2 pi radians equals 360 degrees. And we can derive that pi radians are 180 degrees. So what about 60 degrees? How many radians are there? And 45 degrees and 30 degrees. So what are they in radians? As you can see, so pi radians is 180 degrees. So 60 is 1/3 of 180, so it's 1/3 of pi radian. And for 45, that would be 1/4 radians. And for 30 degrees, that would be 1/6 radians, 1/6 pi radians. And these are special angles. Later, when we are learning trigonometric functions, we will use very frequently of 30 degrees, 45, 60, 90, 135, and 180s, and 270 degrees. We will use them quite often. So you definitely need to know how to convert them into radians. And so let's still review it. Pi radians equal 180 degrees. So what about pi over 2 radians? So how many degrees are there? And what about 3 pi over 2 radians? So the second is for 90 degrees. And the third one is 270 degrees. And 2 pi radians, as the definition goes, it's 360 degrees. And it must be very familiar with those ones. And the same goes as pi over 6 radians, and 4 over 6 radians, and 3 pi over 3 radians. You should memorize those as well. So these are independently 30 degrees, 45 degrees, and 60 degrees. And we have two common ways of testing the knowledge here. First, converting radians into degrees. Say 5 pi over 6 radians, how many degrees are there? And the second common question is 60 degrees and how many radians are there? Or just giving you a not very special degree, let's say 13 degrees, how many radians are there? This is normally tested in an exam paper. And you just need to remember their basic relationships. Pi radians is 180 degrees. So this is like 5 over 6 times 180 degrees, and then that will be it. So it's 150 degrees. And for 1 degrees is pi over 180 radians. So you have 60 times 1 degree. So it's pi over 160 times 60. So it's pi over 3 radian. And for the third one is 1 times 13 degrees, which would be, so 1 times 1 degree times 3, so it's pi over 180 and times 13 radian, so it will be 13 over 180 pi radian. So these conversion problems have been very frequently tested in exam papers, and you should know them. And the biggest convenience for radians is that it can combine the unit length and degrees very well. So for pi, when it is used for unit length, it can be counted as 3.14 as a unit length. And when you're using it as degrees, it represents 180 degrees. So it's very convenient for uniting them. So why is that? Let me give you a graph of sine, a trigonometric function in advance. So it looks like this. And for here, it means 180 degrees, which is pi radians. And the highest point is 1. You see, our x-axis is actually for degrees or radians. But when you're drawing the graph, you can use pi radians as a unit length, which is 3.14 unit length. So it's very good for combining them with the unit length and the degrees.